the next step for us guys is going to be to switch from our flipped matrix back to our original matrix. Okay, and you're going to see that it's going to do something a little bit differently. So if I remove this, I have to obviously replace all the connections. So I'm just going to start doing that one by one. So I'll plug this in here, I'll plug this in here, and I'll plug this in here. Oh, look at that. That looks cool. And then that, and even this one. I'm going to leave flip matrix there in case I need it again. But so this is what it did, right? So basically we went from our 0 to 5 index values and we flipped back over to the 0 to 7, which when you're going from 6 to 8 means that you have 2 extra values in the list. So the pattern only has 6 items, and so what happens is the next 2 items in that list just get perpetuated with the last value. So lines, turn this back on, preview. So lines, see index value 5 there is a radius of 2, and then 6 and 7 are also a radius of 2. That's what I mean by that. So for us, what we have to do is figure out what the length of the list is and then modify it to match. Okay, so to kind of show you what I mean by that, I'm going to create a range of numbers, and it's going to determine automatically how many values are in the list, and then it's going to basically just divide and create an even scaled number for that whole length. Okay, it sounds really complicated, but it's really not. I'm going to get rid of these panels because they're annoying, or that panel because it's annoying me now. All right, so this is what I'm going to do. I need to measure the length of the list. I showed you this before, right? So I go to set and list length. And I can measure the length of the list either from the points or from the circles or from the scaled circles. So what's happening here really is that we need to figure out where we want to, which of these numbers is going to be a constant. Okay, so if I flatten it, it might change. Anyway, that kind of stuff. So for now, I think it's okay to plug it into the points right here, because I know that the number of points is always going to match, you know, the number of cells and all that other stuff. So it's a pretty fundamental number. Let's see. Actually, let me see something. Is that going to be the same? Yeah. Yeah. Okay, so we have the length of our list. Now I need to create, or rather create a repeat, or not a repeat actually. Determine a numerical range, basically. So this is what's going to happen. I'm going to set up a range, and it's going to ask me for a domain range, and then it's going to ask me for the end input is the number of steps. So a domain has 2 values. It has a minimum boundary and a maximum boundary. So I'm going to do this the longhand way, and there's a shorthand way, but we'll get into that later. So essentially, under math and domain, the most basic form of domain is the construct domain tool. Let's see, this was under set and sequence. Sorry, I'm not labeling these like I should. Set sequence, this is under math and domain. This is under set and list. So domain gets plugged into the D, and it's going to request an A number and a B number. The A number is going to be the minimum, the B number is going to be the maximum, and those can be provided as either a slider or a static number. So in this particular case, I'm going to use sliders just because they're more fun. So I'll do a slider from 0 to, this is getting plugged into radius, so I'll just say 2. But I'm going to do a 0.00 so that it's a decimal value. Give it a little bit of a number, 0.25, 0.5-ish, something like that. And then copy and paste and plug another one then into B. Make it a little bit higher. So now when you read the input, it's going to say 0.47 to 1.97, which is exactly what I gave it for the domain. Then we just have to define the number of steps. So if I plug my list length in, oh, actually, I don't know that that's going to do it. 9 steps? Is that right? 8 index values. Yeah, it should be. We'll try it. This might need modification. But anyway, you plug the list length into the number of steps. So what this means is anytime my number of cells changes, so too does the list length. And so too does my pattern. Right? So it's all about making these things smart and parametric to one another. So at this stage, we have a range of numbers in between. Yeah, we have a range of numbers in between, approximately a half and 1.97. And the list length matches the list length of my pattern. So if I plug this in to F instead of this panel, you can see that, oh no, I got a duplicate in there. How did I get a duplicate in there? All right. Well, anyway, so it's essentially functioning, except I've got a duplicate somehow. So anyway, this might need to be -1 or something. I'll figure that out on a break. But so what's happening is now it's reading how many there are here, and it's giving us a range of numbers, and then feeding it in as a scale factor. So instead of doing it ourselves, if I then reintroduce the flip matrix and I switch it over to a different index value, or if I change the number of subdivisions, it's all going to be smart and parametric. Okay, so notice how this item 3 gets larger as I reduce the number of subdivisions. So as I expand it, it gets smaller. Any questions? Okay, and I'm not going to do the flip matrix again, but you get the idea. And let me take a look at how I can get rid of that extra one here. That was unexpected. All right, resuming real fast, guys, just so I can explain what was happening. So in terms of thinking about these things as real objects, right, I have to think about the number of points, which is basically the corner of a page, or the cell itself, right? So the count of cells is always going to be 1 less than the count of points between them, or edges between them, right? So if I have 2 pieces of paper next to one another, I have an edge on one side, I have an edge between them, and I have an edge on the other side, right? Same principle applies here. So what was happening was, because I was reading the points along the tree, the points along the cell, I was reading that as a count that I was then trying to remap in a list of geometry that's applied. So when I created a range, the range is codependent on the number of subdivisions rather than the number of items in the list. So when it read, for all intents and purposes, right here, I bumped it up to 10. When it read 10 points, that meant 10 subdivisions, which gave me 11 numbers. So that's where we got the extra value. And so 2 things you can do to reduce that. You can measure the length of the points and then subtract 1. or you can read the cells instead. So points come out at 11. Cells, if I plug that in and I get rid of the subtractor, will work the same way. Clear? You guys can probably do this kind of stuff on your own now. It's just patterns, so it's really not much yet. All right, let's move on.